A car tyre has a pressure of 1.5 times 10 to the power of 5 pascals when the temperature is 0 degrees Celsius. What will the pressure be at 20 degrees Celsius? Okay, so a nice simple question, and we'll split our page into two, and on this side we'll write down what we know, as we always do. So what do we know? Well, we know the first pressure, P1, is 1.5 times 10 to the power of 5 pascals. Pressure 2 is what we are required to find, because that's what it's asking here. We also know the temperature 1 at the start was 0 degrees Celsius, but we do not work in Celsius, we work in Kelvin. So we have to convert it by adding 273, so that's 273 Kelvin. T2 is 20 degrees Celsius, and again converting that into Kelvin, we add 273, that becomes 293 Kelvin. So our equation that we will be using, we of course get from our equation sheet, and we are looking at pressure and temperature changing. There's no mention of volume, so we don't want an equation with V in it. So this is the one we're using, P1 over T1 equals P2 over T2. So the solution, P1 over T1 equals P2 over T2. Sorry about the mess. So let's just put the numbers in then. So P1 is 1.5 times 10 to the power of 5. T1 is 273. And P2 stays the same because that's what after, and T2 is 293. That gets you 1 mark, that gets you another mark. Final mark is to try and get the answer. So we have to do a wee bit of work for that. We have to get rid of the 293, so we're dividing just now, so we multiply. So it's 293 multiplied by 1.5 times 10 to the power of 5 divided by 273, and that is what P2 is. So P2 equals, and let's just do this in our calculator then. So 293 multiplied by 1.5 times 10 to the power of 5, all divided by 273, and it's 160,989 pascals, but that's a lot of significant figures. So if we've done that in scientific notation, P2 would become 1.6 times 10 to the power of 1, 2, 3, 4, 5 pascals.